Hello everyone and welcome back to the How Machines Work series. In our previous lessons, we learned what mechanical engineering is and explored the simple machines that form the foundation of modern technology. Today, we're going to answer a very important question. Why do machines move? To understand that, we need to learn about force, motion, and Newton's laws. These ideas form the foundation of physics and help engineers design everything from bicycles and cars to rockets and industrial machines. Let's start with a quick review. In Lesson 1, we explored the basics of mechanical engineering. In Lesson 2, we learned about simple and complex machines and how engineers use them to solve problems. Now we're taking the next step. Today we'll study the forces that cause motion and the laws that explain how machines behave. By the end of this lesson, you'll understand some of the most important principles in all of engineering. So, what exactly is a force? A force is simply a push or a pull acting on an object. For example, when you push a shopping cart, you're applying a force. When you pull a door open, you're applying a force. Even gravity is a force. It constantly pulls objects toward the earth. Engine thrust is another example of force. It pushes vehicles forward and allows airplanes and rockets to move. Engineers measure force using a unit called Newton, abbreviated as N. When engineers analyze a machine, one of the first things they study is the forces acting on it. Now that we understand force, let's talk about motion. Motion occurs when an object changes its position or time. There are several common types of motion. Linear motion happens when an object moves in a straight line, such as a car driving down a road. Rotational motion occurs when something spins around an axis, such as a wheel. Oscillating motion is a repeating back and forth movement like a pendulum swinging. Mechanical engineers study all three types because machines often combine them in different ways. Newton's first law is often called the law of inertia. It states that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. The key concept here is inertia. Inertia is an object's tendency to resist change in its motion. For example, a parked car remains parked until a force moves it. Similarly, a rolling ball will continue moving unless forces such as friction or air resistance slow it down. Engineers must understand inertia whenever they design moving systems. Newton's second law explains how force affects motion. It is represented by the equation F equals ma. Force equals mass multiplied by acceleration. This equation tells us two important things. First, increasing the force increases acceleration. Second, increasing mass makes an object harder to accelerate. Imagine pushing an empty shopping cart and then pushing a full shopping cart. The full cart requires more force because it has more mass. Engineers use this principle constantly when designing vehicles, machines, and engines. Newton's third law of motion states that for every action there is an equal and opposite reaction. This means forces always occur in pairs. When you walk, your foot pushes backward against the ground. The ground then pushes forward against you. The same principle allows swimmers to move through water and rockets to launch into space. Although the forces are equal in size, they act on different objects. This law helps explain how machines interact with their surroundings. In real machines, multiple forces act at the same time. Gravity pulls objects downward. Friction resists motion and often produces heat. Applied force comes from a user, motor, or engine. Normal force is the support force provided by a surface. Mechanical engineers must account for all of these forces when designing machines. The goal is to create systems that are safe, efficient, and reliable. Let's see how these concepts work together using a bicycle. When a rider pushes on the pedals, they apply a force. The force travels through the chain and causes the wheel to rotate. As the wheel rotates, the bicycle accelerates forward. Newton's first law explains why the bicycle tends to keep moving once it's in motion. Newton's second law explains how the rider's force causes acceleration. Newton's third law appears when the tires push backward against the ground and the ground pushes the bicycle forward. This simple example shows how physics and engineering work together in everyday machines. Let's review what we learned today. We defined force as a push or a pull. We learned that motion is a change in position over time. We explored Newton's three laws and saw how they explain the behavior of moving objects. We also examined the different forces that act on machines and applied these ideas to real engineering examples. In the next lesson, we'll explore torque and rotation. We'll answer an important engineering question. Why do some machines parts rotate instead of moving in a straight line? Thank you for watching and I'll see you in lesson 4.